Okay, a transformer has primary and secondary windings. Okay, so let's figure this out. Let's go 350. So N primary is and secondary is 1600. So this is definitely a step up transformer, right? It's stepping us up. Whoa, a lot of windings, right? Okay, I like to do this because I'm such a spaz. Let's see. What is the voltage in the primary if there's a voltage of 512? So Vs is 512 volts, right? Has 3.4 amps. So V primary is, we don't know. Okay, and then it's got 3.4 amps in the primary. Right? But then loses to Jeff Merkley in the election. No, I'm just kidding. Okay. The secondary is we don't know. Okay, 100% efficient, of course. Okay, so to find the voltage, I'm going to do this. I'm going to use the simple proportion, right? So voltage primary over voltage secondary is N primary over N secondary, right? So voltage in the primary over voltage in the secondary is 512 equals 350 over 1600. All right, here it is. So now I'm going to go 512 times 350 divided by 1600. And that is 112. Okay, so the voltage in the primary is 112 volts, right? Okay, now let's see. We are stepping the voltage up, so the current is going to step down. Okay, I'll just use the IB formula here, and that is that the current in the primary over the current in the secondary equals N secondary over N primary. They've got something like this going on, right? Okay, so the current in the primary is 3.4. Current in the secondary is that, right? That equals N secondary. 1600 over 350. All right, so now I'm going to go this times this divided by that. 3.4 times 350 divided by 1600. Whoops. 0.74375. Okay. Now, this formula is kind of my pet peeve. It works well in this situation because they did give us the ends, and so we can use it without using that. Ultimately, what's going on, though, is that the power in IPVP is equal to ISVS. Okay, this is power in equals power out, right? Assuming it's 100% efficient. Now, obviously, if it wasn't 100% efficient, right, then you'd put the efficiency right here. So if it's 90%, you put a 0.9 there, and then you'd be all set. Now, to use this, of course, I'd have to use my answer, but it works pretty well, right? I can go 3.4 times 112 equals IS times 512. And now I can just do this 3.4 times 112 divided by 512. And I get exactly the same thing. I secondary is 0.74375, okay? I like that because it really tells you what it really is. It's power in equals power out. And I feel like the IB formula, this thing obfuscates that, okay?